In this video, we're going to start a new kind of chapter, so to speak. The rest of these videos are going to be really geared towards assemblies and things that we can do in our assemblies. So this first one, we're going to look at what's called top-down modeling. And that's where we're going to be able to create parts in the environment of the assembly here. Okay, so let's first, I'm going to open this valve here, and we're going to use create part in place. So whereas before we've inserted our components, we're now going to actually create this part in place. We've used this, I think, before in some of our other videos, but in this one we're going to kind of explain a little bit more here what we're doing. So when you first click that, you're going to get a window that pops up, and we have some options here for how the origin is going to be. So if we select this first one, the origin of the entire assembly is going to be the origin for the part that we make. We can offset the origin from the assembly, and that just means, you know, your Z, Y, and X are also going to be in the same orientation, but we can offset that and move that somewhere else. What we're going to do is we're going to do by graphic input. This means I'm going to get to select where the origin is. In this case, we're going to select it to be around the outside of this hole here, because we're going to create some brass plates that go on the end here. And we're going to have it set up so that we can edit the part in place after we place it. So I'm going to click OK here. And over here, we're going to make sure that our template is selected to ANSI inch. So if you were making, let's say, sheet metal parts from the previous, you'll need to make sure that you switch this back to ANSI inch part, or if you're using metric, you'll use metric. Now, I will go ahead and say I do have a bit of an issue here in that I am in the inch environment. And we're going to use create part in place. Now before, we've used insert components to bring in our parts, or maybe even just clicked over here on the part library, but here we're going to use create part in place. Now before I do this, I want to make sure that I am set up for the environment that I'm going to be using. So if I'm going to be using metric, I want to make sure that my templates are set for metric, because if not, you'll only get options for ANSI inch. So I'm going to first go back here to File. Under New, I'm going to edit this list to be my ANSI metric. I'll click OK, and then I'll go back to my part. So now we'll go to Create Part in Place. And when we first do this, we're going to get a little window that pops up. And this little window, the first things that we really want to be concerned with is what is going to be the origin of this new part. So the first one, coincident with assembly origin, that means the origin of the assembly is going to be the origin of this part that I make. So even though I'm wanting to make a little brass plate that goes on the edge here, if I select this one, I can't turn here, the middle of my assembly is still going to be my origin. Offset from assembly origin means essentially what it sounds like. We would still have the same the same directions for our origin, but we would offset that to a different location. What we're going to use is by graphic input. This is going to let us choose where we want to place the origin, and it's going to orient it accordingly. Additionally, we want to make sure that we have selected create component, then edit in place. This is going to let us start this part and then edit that part in place of this assembly. So we'll click OK. And before we try to place this, we're going to go over here to our command bar, and this is where we needed to make sure that we were in the right environment. The first time that I did this, I was in inch, so I had to go back and edit that. And clicking options just brings back up this window. So make sure that you've got that selected there. We want to make sure that we're in ANSI metric part. So if you were making sheet metal parts from last time, you want to make sure that you have this changed to ANSI metric part. We can also go ahead and select our material. We're going to make this out of brass. So you'll see all your materials labeled here. If you don't see your material, you can select the material table and select brass, yellow brass from there. All right. So the next thing we'll do after we get all this situated away, we're going to come down here and select where our origin is going to be. Now I want my origin to be right about this this circle here, so I'm going to click there and I'm going to click accept. Now we're going to give this part a name. I'm going to name this end cap. And I'll click save. And you'll see it's going to think about it, and when it's done, you'll see my assembly turn ghosted like it does when we go to edit a part. Okay, so now we want to get to work on making this part. And what's really nice is we can use existing geometry from the parts that are inside of my assembly to make this new part. So for example, we can go ahead and extrude. I click extrude from this face here. Now we'll need to make sure and go to tools. We'll need to make sure that piers has been turned on. So ours has been turned on, and you'll see I can now actually select the face, profile, and geometry from this part. All right, and we're going to extrude this. So I'm going to right click to check yes, 10 millimeters. So we'll extrude that out 10 millimeters. And we just used a face from a background part to start making our new geometry. Now I want the inside hole to match the inside hole of our valve. So what we're going to use is under surfacing, we're going to use our face relate, or sorry, not face relate, replace face, which I may need to find it again here. Replace face. All right. I want to replace this face with this face. And you'll see that's going to bring in that hole so that this inside cylinder matches the inside cylinder there. All right. From there, I'm going to go back to home, and I've got these holes from this previous cutout, but they don't really have any meaning to them. So I'm going to, under the drop down for the hole tool, I'm going to say recognize holes. And you'll see I get these two different types of holes. So I'm going to select, I'm actually going to go ahead and select the options for this, these four holes here, because I happen to know that there's going to be an M8 bolt that needs to go through there and screw into my valve body. So I'm going to keep this as a simple hole. I'm going to say ANSI metric, and we're going to turn this to general clearance, and I need to change this to M8. And we'll keep it as a close fit. I like close fitting holes. And we'll click OK, and you'll see that's going to update these holes to be the correct size. And these are actually holes, right? These aren't just cutouts anymore, which is a really, really nice feature there. Okay, now if we look at this, we need some of this geometry to go back into the ball valve and actually interface and match the curvature of the ball valve. So what we're going to do is we're going to project some of these edges that we have here on the side of our housing onto our face here. So I'm going to select project a sketch, and when this window comes up, I'm going to pause for a second because I do want there to be a little bit of a clearance here so that my part fits in there nice and snug. So I'm going to say project with offset. All right, we have to make sure that we do this before we get into it because it, for whatever reason, does not add it if you go into options and add it after the fact. Okay, and I want my offset to be, let's say 0.25 millimeters. All right, and I'm going to come in here and I want to select first this inside lip or inside edge of this lip. So I'm going to select accept, and again it wants to know which direction do you want to offset. I want to offset onto the inside, and then I'm going to use that to extrude. Now I want this to extrude. If I look here from the side, there's a pocket in here. I'm going to go to View, change this to, yeah, full wireframe. Kind of shows me here what I would like to see. So you'll see we've got our ball here, and I want this to be able to come in and interface with this ball. We're going to have it eventually, have a nice little cupped shape here so that it fits and interfaces nicely. So we're going to just extrude this. I think about 16 millimeters is correct. Okay. We'll make this solid again. So you can see we go here. We're currently touching the ball, but that's okay. We're going to use some of our tricks from surface modeling to make this easier. I'm going to hide the rest of my valve body here for just a moment. So to do that, all I have to do is hover over one of my features and say hide, and that's going to hide the whole body there. Next, I'm going to use enter part copy, which is up here under clipboard, enter part copy. So this is going to copy a face or part from other parts in assembly. So we want to copy the face of this ball valve. Yeah. Okay. So I'm going to select the part, and then I'm going to select the face that I would like. It took me a second to remember how to do that. Okay. I'm going to hit Control Q to hide all of the rest of that. Now you'll see we've got these holes. That's not going to allow us to do our cutouts like we want. So we're going to have to get rid of those holes. So we're also going to need a little bit of an offset so that this doesn't interfere here. So what we're going to do to just fix this is we're going to create an offset. So under surfacing, we're going to go to offset, and we're going to select this surface for my offset. We'll click yes. And we're going to make this offset by 1 millimeter, but we want to also make sure that remove boundaries has been checked. That's going to make sure and remove our holes here. So make sure remove boundaries is selected, and then you'll see my arrow down here. I want to make sure that that's pointing outward. Okay, so we've got our 1 millimeter offset boundary there. And next, let's go ahead and hide my enter part copy. I don't want to accidentally select that. Let's turn back on my my parts here. Now let's turn back on our part for just a moment. So let's right click on feature, and we're going to say show. Now something I want to notice here is that my ball doesn't look like it goes all the way to the middle. It probably goes right there at it, and I want to make sure that that goes all the way through. So what we're going to do is let's hide this again, and we're going to use our extend tool to move the inside of this circle in. So let's go up here to extend. Here we go, extend. I'm going to select this inside here, right click to check, and you'll see I get to move this in. We just want to make sure that we move it in plenty so that it for sure is going to deal with that hole. Okay. So let's now go back and show our solid again. So we'll right click a hole, we'll say show, and that turns back on, and you'll see this definitely goes in past the hole. And what we're going to use next is Boolean subtract to subtract from the solid. Okay, so back to home. Under my add body, we will find subtract. I want to subtract from this body, and I want to use this as the tool. Okay. Now you'll see we want to flip this so that the inside is the part that gets removed. So this arrow is going to be what determines what part gets saved and what part gets deleted. So we want to delete the inside part of that. We'll click the check mark there, and now I have this little cup. If I hit Control Q to turn all that back on, you'll see that fits on there quite nicely. Now on the outside here, we want to add a hex shape so that, we can put some clamps or something on this if we needed to. So what I'm going to do is I'm going to use polygon by center. I'm going to lock onto this face here. And I'm going to touch the center there so that it makes sure it goes out. And I believe this needs to go out 33 millimeters. Okay, and then I'm going to highlight that region. And we're going to bring this up, not subtract, but add. We're going to bring this up 20 millimeters. Okay. I'm going to hide my sketches, hide my PMI. Now we want a counter bore in the center here. So we're going to draw a circle on the outside here. And I've got here that this is going to be 50 millimeters in diameter. And as far as its extent, I want this to actually go back to where the plate is. So if I hit K, I can select these points, and I'm just going to select the edge here of my surface. Okay. And I kind of want to round the outside edges here, kind of like you see like on a nut. So let's get our line tool, and I'm going to get this mostly sideways, and in the flat space I'll hit F3, and that locks me to the middle side plane. So if I hit Control H, and I'm even going to rotate this, I can now draw. So I'm going to draw on this edge. I'm going to kind of come down here, something like that, and then I'll add some dimensions here. So from this outside edge to the end there, I think I want that to be 8 millimeters. And then I want my angle here to be 20. Okay. Now we're going to use the revolve tool for this. And I'm going to change this to single. And I can select a single line. And you'll see I then get my little torus. I'm going to move that to this middle axis. I'm going to change my extent type to make sure it's 360. I'm going to cut. Alright, so when I hit this, it should start to try to cut that out. I'm going to say I want to remove material on this side of the line, and you'll see it just goes around and cuts that out. We get a nice profile there. I'm going to hide that. We don't need to see our live sections. Alright. And we're almost done here, so we're just going to round off a couple things. So we're going to round some of these edges to 2 millimeters. So we'll round these off. I'll round this outside edge there. I'm going to right click to accept it, and that's going to let me then round that inside edge there. And then we're going to use our chamfer tool. We're going to chamfer these insides as well. We're going to chamfer them to 2 millimeters. Okay. So that gets our part there like it's supposed to be. And I think as far as this part is concerned, that's what we wanted to do. So I'm going to save that, close and return. And that gets us our part. Now there's one more thing we want to do, because there's some things we need to understand about these making parts in place. When we make this part in place, he doesn't have any relationships. He is a free agent. He can be dragged and moved wherever he so desires. So we need to give him some relationships. Alright, so we're going to use our flash fit here. And I'm going to give him some relationships. I know that I want that hole to line up there. I'll say that hole there. And I'm going to drag this guy out just a little bit and say that face needs to be related there. Alright, so now that he's fully constrained, he's in place. So I'm going to save this. All right, because we want to mirror this to the other side, and we're going to do this in a little bit different way. We're actually not going to use a mirror tool to do this. While we could, there's another tool we want to talk about, and that is capture fit. So I'm going to select this guy, and I'm going to go right here to capture fit. And that's going to bring up a window, and that's going to show these relationships, and I'm going to say learn these relationships for this part. So I click OK. And now, whenever I bring in this part, this end cap, I'm going to automatically be prompted with, okay, where do you want these things related? So the first hole, I want related here. The second hole, we can relate here. And then this face will relate here. So it's just another way of being quicker with our relationships. Okay, and that does it for this part, for this assembly. Like I said, we got more tutorials kind of like this where we learn some new tricks for making assemblies much easier for us. Can you imagine trying to make this part outside of this assembly? It would be much more difficult and much more time consuming. So I'll see you in the next video, and as always, let me know if you have any questions.